All right, so for 3.5, we're going to be again extending our discussion on two-column proofs, and this time we're going to lead it more into the direction of segment proofs. Okay, so keep in mind for segment proofs, there were three important definitions that you needed to remember what it means to be congruent: the definition of congruency, the definition of a midpoint, and also the segment addition postulate. Okay, those are three things that we need to keep in mind when we are writing segment proofs. Okay. So if we look up here, we got number one up here. So we are given that HW is equal to CT and HR is equal to GT. Okay, so we see that over here in our picture, we have this segment right here, and we can see what they're talking about when we hear HW, CT, and those other terms. Okay, so that's what we're starting out with, and we're asked to prove that RW, this segment, is equal to CG, this segment. Okay, and we have to write a two-column proof. Okay, so luckily they gave us all the statements and they just want us to fill in the reasons. Okay, so if you look right here, statement A states that HW equals CT, HR equals GT. Okay, that is just our given statement from up here. They just took the given statement and wrote it down here for our first statement. And that is also going to be our first reason, is that the reason that we have statement A is because it was given to us. So now we go from statement A to statement B. So statement B states that HW equals HR plus RW and CT equals CG plus GT. Now, if you notice up here in statement A, we don't really have enough information up here to kind of tell us where are we getting all this other stuff from. But if we look over here in our picture, it kind of makes more sense. Okay, so we can see right here, HW, that's the long segment right here, is equal to HR plus RW. HR and RW, same for this one. CT is my long segment right here, and I've got CG plus GT. So if we remember what the segment addition postulate states, it states that if I have a big statement, a long segment, such as HW, and I break it up into two smaller segments, so for this one, HR and RW, then the length of the two smaller segments will equal the length of the whole segment. That's what the segment addition postulate states. So because of that, getting statement B, we use the segment addition postulate. Okay, so let's keep moving. All right, so statement C says HR plus RW equals CG plus GT. Okay, so if you notice, this first statement up here at statement A, HW equals CT. Okay, so that's what we had for our first statement in statement A. And then right here for statement B, we had HW and CT. So HW, HW, CT, CT. So what they did right here is they took the first sentence from statement A and rewrote it for statement C using what we learned in statement B. So we learned that HW is equal to HR plus RW. So HW up here, HW rewritten as HR plus RW right here. CT right here is down here as well, rewritten as CG plus GT. So we took what we learned from B and A and combined that information to get our statement C. Okay, and so because we're doing that, because we basically rewrote the first statement in A as the first statement in C, we were substituting in the values that we learned at stage B. Okay, so this is using the substitution property. So now to go from C to D, the only thing that changed was this last term. GT turned into HR. Okay, so now we got to think, why were they able to make that? So again, if we go back up to statement A, the second statement in segment A says that HR is equal to GT. So that tells me that anytime I see HR, I can replace it with GT and vice versa. So that's what they did here. They had GT and they replaced it, or they substituted it with HR. So to get from C to D, I once again use the substitution property. And so now lastly, I need to get from D to E. So if you notice, both sides have an HR, and when we get down to segment E, the HRs are missing. So we had to get rid of those HRs somehow, so we had to subtract HR from both sides. And so when we did that, we were just left with RW equals CG. So to get from D to E, we had to use the subtraction property.